Hey Geometry, today we're going to do our next lesson, which is 10.2 arc measures. So arc measures is a pretty easy topic, and I feel like we'll have an easy time. Now, what exactly is an arc measure? Well, we already have worked with this when we were doing 11.1 and 11.2, the circumference and area part. This inside angle, where I used to call it theta, we're going to call that a central angle. Okay, let me put all the definitions in the description so I don't have to waste time writing it. But this one right here, the angle on the inside, is called a central angle. While the angle out here, you could describe how wide open this is a arc measure. Okay, an arc measure. So what's important though is the central angle is equal to the arc measure. So they're the same size. So if I were to have a circle like this, and I said this is 90 degrees on the inside, you know this arc measure, how long from here to here, is 90 degrees, okay? So there's the same inside and outside. That's a really nice rule for us. And there's two type of arcs. Let's call this A, B, C. There are minor arcs. So minor arcs are just arcs that are less than 180 degrees. So like arc AB would be less than 180 degrees. But major arcs are greater than 180 degrees. So major arcs would be like arc ABC. And when I say arc ABC, I start at A, pass by B, get to C. And that's more than 180 degrees. So you have minor arcs, major arcs, and exactly at 180 degrees, is a semicircle. So that's exactly 180 degrees. Okay? So those are the terms, and let's go through some problems. Okay, you could pause the video if you need to copy this down. But here's going to be an example of a problem we could have. Here's 120 degrees, and here's 80 degrees. All right. And very important, this is not a straight line, nor this is a straight line, so we can't use vertical angles. Okay? All right. So, if you finish pause, we're going to go through this, and we're going to do two things. Tell me how long it is, and tell me if it is a minor, major, or a central angle. Or, I'm sorry, a semicircle. Now, let's first look at... There should be more straight line. Let's look at TQ. Now, the first thing about TQ is that when I say TQ, you have to make sure you're understanding. What do I mean? Do I mean the long way around or the short way around? If I don't have a variable in between T and Q, that implies the short way around. So just from here to here. So what is here to here? Well, if this inside angle is 120, this outside arc measure is also 120. So this right here is 120 degrees, and that would be a minor arc. Okay? QRT, so QRT. So the difference between TQ, or I guess I could have said QT, and QRT is that if I say it like this, you know I have to pass by R to get to T, so I have to go all the way around this way. Now, if I have to go all the way around this way, I need to add all the pieces. So I need QR, which I know is 60. I need this one, and I need this one, which I know is 80. So how do I find this one? Well, if you can't use vertical angles, I just looked at it and you might think of it, but you can't use vertical angles because these are not, this one is definitely not a straight line, QS. So what we have to do is take all the pieces you have and subtract that out of the total circle. What is a total circle? That's 360. So I got to do 360 minus 120 minus 60 minus 80. And you could pull out your calculator, or you could do it in your head, but you should end up getting 100 degrees. Okay? So if this central angle is 100 degrees, the arc measure is 100 degrees. So what are we going to do with that information? Well, if we're looking for QRT, which is this arc from here to here, we have to add up all our pieces. So 60 plus 100 plus 80. So that should be 240. Well, if that's 240, that's a major arc. TQR, so T to the Q to the R. So T passing Q to get to R, you include 120, you include 60. 120 plus 60 is 180. Since it's exactly 180, that's a semicircle. QS, Q to the S, that's 60 plus 100, 160, so minor. You need to be exactly 180 to be a semicircle. And RTS, R to the T to the S, so you see how that go this way, because I have to hit T before I hit S, so I can't go like this, is 60 plus 120 plus 80, which should be 260, which is a major, okay? So pretty easy things here. Just straight identify the angles and then add them when it's necessary. All right, so our next one is going to be talking about congruency in arc measures. So what is happening here? We have circle C and we have circle D. I want to know if arc AB is congruent to arc EF. Now, how can I tell? I need two things to test if they're equal. First, I need to see if the arc measure is the same. So if this was 100 degrees, this would also have to be 100 degrees. So first thing is arc measure. The second thing we need to check if the radius is the same. So the radius have to be the same. So I could say this is like 5 inches and this is 5 inches. So you need two things to make sure things are congruent: the arc measure and the radius. Okay? So in order for arc AB to be congruent to arc EF, you need the radius and the arc measure to be the same. If one of them's different, they're not congruent. So they have to be congruent by passing those two things. And now I'm going to draw a couple examples of said things. All right, so let's see. First off, you could pause if you want to write these down. But after you finish pausing, let's go through it. All right, so we need two things to make sure they're the same: the theta, which is the arc measure, and the radius. If we know the radius and the theta is the same, then we know the two arcs are congruent. So let's first compare CD with EF. Well, CD and EF, the arc measures are the same. This is 80, this is 80. So that means the arc measure is 80 degrees, and this is 80 degrees. So that checks off. We're good with that. Now, the radius. I don't have any indication on a radius, and that's on purpose. But if this is truly a circle, and this is truly the center, then the radius is the same size no matter what direction I go. Which means this radius should match this radius, should match this radius, that should match this radius. Since they're in exactly the same circle, you know for a fact that the radius has to be the same. So that checks off. So CD, arc CD, or I should say measurement of arc CD, is congruent to the measurement of arc EF. Okay? So we put a little M for measurement of CD is congruent to the measurement EF. Okay? And let's go to the right side. All right, the right side. We have CD on the outside and AB on the inside. Now, you might look at it and say, yeah, of course, that's not congruent. Well, let's just make sure. First off, if the theta is the same, I didn't mark the theta, but since this is the same angle, so this is the same line, right? So the angle has to be the same for AB and CD. So if this was 30 degrees, or I don't know, whatever, let's say 90, then this has to be 90. So from the picture itself, I don't need to put a number because I know it's on the same actual angle. So for a fact, the theta or the arc angle is the same. But the problem is the radius is different because this is shorter. I need to put a letter here, E. EA is shorter than EC. It's for a fact it is because EA is part of EC. So there's no way they're the same size. As soon as we realize that, that means the radius is not the same. So these are not congruent. Okay? Or you would just write like not congruent. All right, those are all the problems. As always, the Zoom, as for now at least, the Zoom is mandatory, so come by and by. I'll give a couple of minutes for you guys to have time in class to watch the video.